final lesson in this module, we're going to talk about exception handling and the basics of it. So there's one more way that we can control this float, and that's through exception handling. Exception handling is the process of catching an error that would have otherwise halted our execution of our code. This allows you to potentially recover from a somewhat fatal position or situation. Exception handling is a really powerful tool, but sometimes it can be overused or used improperly. Remember these simple rules when doing exception handling. And I really want to emphasize this. I've seen multiple times beginner Python programmers use exception handling the wrong way or too much. And so be really, really careful about this. First off, only catch exceptions that you can gracefully recover from. That means that you know that even though you had an error, you know how to fix it, or you know how to get yourself to a state where it's not going to be a big issue. It's okay to have exceptions in your code. That means that you can have errors. They're meant to be there for situations that you didn't account for. That's okay. It's okay if the user does not use your software the way that you anticipated. Most likely they won't. And that's okay if there's exceptions. Just be prepared to fix your code based off of those exceptions. Also, don't try to account for every exception possible. Only catch exceptions that you know you're likely to run into and that you know you can gracefully recover from. So don't feel like you have to catch every type of exception that's out there. If you do need to catch all exceptions, so for example, if this is an always running script, like a web server or something that's checking for connections or those types of things, then log the exception. Make sure that you're keeping track of that. Exceptions and error handling is a powerful tool that's meant to tell you when something went wrong, something that you didn't expect as a programmer. If you catch all of those and then don't keep track of them, then it's going to make it really difficult when you do run into a bug that you did not expect. Finally, keep your try blocks as small as possible. Don't create a try block that spans a ton of lines. I've seen a project where they started off the script with a huge try block and everything inside of that was in that try block. You should not be doing that. Make sure that you keep them as small as possible. Let's go into what this all means. Now, this is a lot of upfront knowledge that maybe you don't fully understand because we haven't gotten into exception handling. But I really want to drill in that exception handling should be the exception. Let me say that again. Exception handling should be the exception. You should only be doing it when you absolutely know that you have to do it. And there are situations that you will. And I'll show you some basic situations where you're going to be needing to do this. Let's talk about, though, some of the common types of errors. The official error lists can be found here in this documentation. And when I click on this, you can see all the built-in exceptions. And there's quite a few of them in here. I'm not going to go over all of them, but I am going to cover some of the common ones. We have a value error, which means that an operation encountered an invalid value. We have a type error, which means an operation is performed on a value of the wrong type. For example, if we did 1 plus the string of 1, that won't work. It'll raise a type error. Name error means that a variable name was used that hasn't been defined. Zero division error, hey, we've already ran into this today. The divisor in a division operation is 0. And then overflow error. That means that the result of an arithmetic operation is too large. So how do we catch exceptions? Well, we use them with the try and except statements. To catch an exception, you need to first have the try. And when you have a try, then you're going to try the following indented code. Then you're going to have an except statement. And if an exception is raised in the try block, then you run the following indented code. Almost like a try and else, or a if and else statement, except a try is also a try and except works a little bit differently. Let's look at that and how that works. So here's a small example. Let's say my num is valid. We have a variable called num is valid, and we've set that to false. And what we're doing is we're iterating over our number, or we're iterating in a while loop until my num is valid is true. That means that we're going to keep prompting the user for a valid number until they give us an actual valid number. And if they don't, then we're going to keep going. So we prompt them for a number, and then we're going to try to convert that number into an integer. If that successfully happened, then we set num is valid. This becomes true. When we have while not true, that means we're going to break out and we're going to print the number. Now, if they didn't put in a number, specifically an integer, then it's going to raise a value error. But we want to catch that and tell them, this is not an integer. You need to give me an integer, please. So let's go through this execution. So I had please enter a number, and I typed in meh. And I got back, this is not an integer. Then I entered a number and I typed in test. And I said, that is not an integer. Finally, I entered in a number and I set it to 12 and I got the value 12. So let's go through this one more time. Num is valid is equal to false. I'm doing a while loop, means I'm going to continuously do this until num is valid is actually true because I have the not in here. So I'm waiting for a valid number. I'm prompting the user for that number, and then I'm going to try to convert that number into an integer. If that's the case, then I'm going to set num is valid to true. If it's not the case, then I'm going to get an exception on line 9 right here. An exception will be raised. I'm going to catch that exception by using the except and then value error, because I know it'll be a value error that'll be raised. And I'm going to print and tell the user that's not an integer. So this is how you use a try and except block. Let's look at another example where we actually chain exceptions. Let's define a safe division function. So when we divide by a number, we want to make sure that, first off, the two values are actually numbers and not one of them's a string. And then also that the second value, or b, is not 0. So I've got two exceptions here. First off, I do my try where I print out a divided by b. And then if I get a type error, that means that I cannot divide an integer by a string. And so there's something weird going on there. So I'm telling them that a and b must be numbers. Now, if I got a 0 division error, then I need to tell them that b cannot be 0. And so let's test this out. We did a safe division of 10 and 5. A and b must be integers. And then we did a safe division of 10 and 0. B cannot be 0. Finally, I did a safe division of 10 and 2, and I got the value of 5. Next up, in the next video, we're going to go over an in-class assignment on how to use these exceptions.